Okay, so let's be practical about the work, and let's evaluate it for some general force, and let's do this in terms of Cartesian coordinates. So let's say the force has an x, y, and z components. So this becomes fx I hat, right? This is the x component of the force, plus fy j hat, plus fz k hat, dotted into dr, which in xyz coordinates looks like, right, a little displacement in the x direction. The I hat gives you the direction, little displacement in the y direction, little displacement in the z direction. And so we do a dot product, right? So I hat and I hat is 1, and I hat with j hat or with k hat is 0. So the fx only goes with the dx, plus the y component with the y component, fy dy, that's the only thing that survives with the fy, and the only thing that survives with the fz is the dz. So we really have an integral that looks like that, or rather an integral of the x component, right, the part of the force along the x direction integrated along the x, and the part of the force in the y direction integrated along y, and the part of the force along the z direction integrated along z. So it looks something like that. But let's say that we have let's say the gravitational force. The gravitational force. So the plane, it may be xy plane, and gravity is in the z direction. So the gravitational force on some object of mass m would be minus mg k hat for the z direction. So let's say we want to find the work done by gravity. So we're integrating. So we only have a term like this, right? These two would be 0, and this term would be minus mg k hat dot dz. Well, let's write it all out, and then we'll do dot dr, which is dx I hat plus dy j hat plus dz k hat, right? So we replace this with this, and then we've left this like this, but now we'll evaluate that, and of course that will give us a minus mg dz, and so we have to choose the limits of integration. It's from z1 to z2, say, and that becomes minus mg times z from z1 to z2, which is minus mg z2 minus z1. So let's say if we start at z1 is equal to some height, let's say L. If z1 equals L and z2 is ground level, say 0, then the work becomes minus mg times z2, which is 0, minus z1, which is L, and that becomes mgl. So there's mgl work done on this object if it goes from a height L to ground, and notice that work is positive. If instead, we don't need a we here, it's just if z1 equals L, and so instead if z1 is equal to ground, 0, and z2 is equal to L, so we launch the object straight up, then the work done in this case is minus mg. Z2 is L minus 0. In this case, it's minus mgl. That's negative. And so when we launch the object up, gravity does negative work. When we drop the object or launch it downward, gravity does positive work.